all conveniently next to the refrigerator. I would like to think we want to start with the refrigerator.
Yeah.
So I did mention that the lab manual does have the procedure in it, but we'll walk through most of it. Some of you did mention that the sketch is going to look complicated. It's really not that complicated. So I'm going to try to break it into sections so that, like, you see what I'm talking about. It is kind of color coded with the lines like between two units. So the basic refrigeration cycle is going to have four main components, right? You have compression, you have evaporation, you're going to have condensation and expansion, right? Those are your four things. So these different colors are basically in between each one of those four components. Okay. So as I go through, just kind of keep that in mind. Sure. Let's get that. So our basic objectives are going to become familiar with that basic refrigeration cycle I just pointed out. We're going to be able to generate a pressure enthalpy diagram. It's kind of that little boat-shaped looking graph we learned in general thermo. Yeah, pressure enthalpy. Okay. And then you'll be able to calculate the isentropic efficiency for the compressor. Okay, so those are kind of the main three things we're going to look at. There's two parts to the lab. There's going to be operation with a thermal expansion valve, and there's going to be one with a hand expansion valve. Okay, so we're doing two separate ones. For the hand expansion valve, well, I'll start with the thermal expansion valve. Okay, so this valve is kind of like a control valve, or it is a control valve. So once we get this open, as the pressure builds up, as it gets hotter, the pressure is going to build up. There's a little piece of tubing that goes all the way around, a capillary tube. It can expand and contract inside, and as the pressure builds up, it pushes down on the spring on the inside, and that allows more flow, kind of like the regulator. When you push on the spring, it opens the flow path to get more flow through it. Works the same way. So as it gets really hot on this end, it'll allow more flow through to cool it back down, and when it gets too cool, it pulls off and lower itself, lower the flow rate. And so while the experiment's going on, you're going to see the ball kind of go up and down a little bit as it's regulating itself. That's normal. Okay? So for the thermal expansion valve, there's a series of set of valves. If you forget, it is listed up here. We're not using this section, so we want to close this valve on top, keep this valve closed, and we're not going to use this one at all, so we'll keep this closed. Okay? Not including our two valves, this valve and these two valves are going to be open at all times. Okay? So again, this one, and this one are closed. These three open, and then one of these two is going to be open, the others will be closed, depending on which part of the experiment we're doing. Okay? So for the TEV, what we're going to be testing is our two fans. So for one run, we're going to have both the evaporator and the condenser fan on, and then for the other run, we're going to have the evaporator fan off, and we're going to see how that influences the system. Okay? The switches are all located over here. Just make sure it's plugged up in the back. You can flip your fans on, and then when we're ready to start, you can flip your compressor, and then you can go ahead and open up whatever valve you want to start with. Okay? For the thermal expansion valve, just to make sure we don't flood the system, you don't want to put liquid into a compressor, right? We don't want to open this one wide open at the start. Normally, at this temperature, when it's sitting idle, it's probably fully open. So if we open it all the way right now, it's probably going to flood the compressor. So what we're going to do is once we turn our compressor on, we'll slowly open our valve into the ball or the float. Hits around 40, 45 in the rotometer. Okay, that's in millimeters. We do have a conversion that should have been posted on Google that will tell you what the pounds per hour is. So you can just use that to get the actual mass flow rate. This is just in millimeters. So we're open it slow until it hits 40 to 45, okay? And then we leave it be. Eventually, it's going to drop down, and then we can slowly open it a little bit more until we get it fully open. We want to get it fully open. That way we're not influencing the system of the valve, we're just letting it do its own thing, okay? But once you finally get it open, then you can let it run and get to steady state. At some point in time, your two pressures, your discharge side, which should be positive pressure, and your suction side, which should be a vacuum pressure. Okay. Eventually, you get to steady state, and you measure those two, and then you're going to start taking temperatures on either side of those components I mentioned earlier. So they have these little temperature wells. You're going to fill them up with water, just so we have some kind of heat transfer fluid. You can take your temperature data logger, put the thermocouple inside, and just wait for it to steady out, and log it. So we have 6 of those temperatures on either side of the inlet and outlet of your compressor. inlet and outlet of your condenser, which is here, that's a well up here, and then inlet outlet of your evaporator here again. Okay? So you got temperatures, you got pressures, you get the volts and the amps for your compressor power. So take those as well. Let's see. In addition to that, I'll just run through this real quick so you can see. They also provide you a sample of your data sheets. I would just redo these in Excel. Reason being, they don't have enough for all the things we asked you to do. Like when you get to port 2, there's 3 different flow rates you're going to use, but there's only space for 2. Just redo them in Excel. That way you have enough space. But the first part has all of your like numerical data. So your pressures, the flow rate, all your temperatures, refrigeration effect you actually calculate, so you don't have to put that on the data sheet. There's going to be a part where you have to do a kind of a visual inspection, or you want to see whether there's liquid, vapor, or a mixture in each of those components. So you can look, we have clear glass tubing. You can look and see if there's liquid coming in, a mixture, or vapor. Same thing leaving, and you can just write down what it is. You can do something similar, but this is going to be more of a touch sensory type thing, where you actually have to touch, let's say, the inlet of the evaporator or the outlet. Is it cool? Is it warm? Is it hot? Be careful with the compressor. That one gets kind of hot in excess of 100 F, probably 120, something like that. So be careful when you touch that one. Just kind of, or touch it with the back of your hand or something to kind of check it. You'll know if it's too hot, to just kind of grab it because you already have the temperatures with it. But you just basically want to confirm that the temperature is measuring a hot temperature and it feels hot, kind of thing. Okay. So yeah, it's the hot cold. Each component. Each part of the system is going to have, like, say, for the evaporator pressure, you want to look at it and see if it's high or low. Okay. Basically, the system is divided into 2, a high and low side. So you're going to have one or the other. Generally, where that's at. Should I tell you where that's at? Mm-hmm. Okay. So, if you look at the 2 parts that are kind of regulating the pressure, which components? We have evaporator, condenser, expansion, and compressor. Which 2 kind of regulating that pressure? Where's the pressure changing in your refrigeration system?
Condenser.
Compressor for sure. And then, expansion. Okay? So basically, those 2 points on either side, it's going to have to be a low side, and the other one's going to be the hot side. If you get confused with where the low pressure is at, where is it tied to the plumbing? And on the discharge side, that's going to be the high side. Okay? So you just make a note of your evaporator pressure is at the high or the low side. Is your the pressure of the TEV outlet high or low side? There's only 2 pressures though, so most of these are going to be, half of these got to have the same pressure, the other half's the other pressure. Pretty straightforward, okay? So hot, cold, warms, high and low, vapor, liquid, mixed, and then you actually have your numerical data. So just basically just make sure you input all the data, okay? And again, we're doing this for the fans, both fans on, and then just the condenser fan on. We'll flip this off over time, okay? That makes sense? So we're just setting, slowly allowing this to get to 45, and slowly opening this while not allowing it to flood. You let it get to steady state, you take all your measurements. Flip the fan off, let it get to steady state again, take all the measurements. You don't first part. Pretty straightforward, okay. For the second part, we're gonna close this, okay? You're gonna put your fan back on, and we're gonna start using the hand expansion valve. So, what we're going to do is try to operate this in the 3 different regimes. You have your normal, which is going to be around 40 to 45. You're going to have a starved condition, and then you have a flooding condition. So that just means that the temperature coming out of the evaporator is going to be too hot or too cold, basically. Okay? But we're going to see how that influences the rest of the system. And you're going to go through the same process. Once it gets to steady state, you take all the same measurements. Okay? This is hard. It's hard to set it. The little spherical float we take from the widest point, not the top or the bottom. You take it from directly in the middle. So you put that one as close as you can to whatever number you want. If you can get it to 40 to 45, we'll call that normal. The manual list is 60 as flooding. It's hard to keep it at 60 without it walking up. At that point, it's probably going to flood it. So if you can get it closer to 55 and let it hang out there, record that. again, we have that sheet in the moodle that tells you what that mass flow rate is anyway. So you just go pick that one. Okay, it's fine if you don't get exactly 60. Same thing for the starved condition. They say 10 millimeters. If we could get to stay at 15, it'll still be starved. Okay, so wherever we can get to stay in those zones, like just go ahead and mark it. For the pre-lab report, you could just say 10, 45, 60. That's all. Okay, you'll see whenever you go to this one's very difficult to adjust. I'm not sure if it's designed that way or what, but or if it's just old. But we normally can get it to hang around at some point. I can come help you if you need to. Just remember before you start to fill all your temperature wells up so that they're all getting in steady state. Otherwise it takes longer. Getting in steady state takes, I don't know, maybe 15, 20 minutes every time you change your conditions. So I'll probably try to prep it too before you get in, just to kind of maybe help you get that first one. We'll just pretend for your pre-lab procedures that you're coming in and starting up. All right. Some safety for this one. They have, it's kind of hard, but they have, a little grating in the back so that you don't stick your fingers inside the fan blades. The glass sections, we do touch everything. You're mostly be touching on the copper, but don't press too hard on the glass. You will crack them. There's a pressure shut off automatically at I think 27 psig. But if it gets to 25 and it's starting to go over, either shut it down or come tell me. If you see frosting on the expansion side, turn it off or come tell me. If you see a bunch of liquid just like fully flowing out of here, this is kind of the last stop before we get to the compressor inlet. Shut it off and then come get me. If you see a little bit running thing, if you see anything wrong with the shut off, come get me. All right, we don't want to break this thing. You might notice a little bit, there's like a little bit kind of here. As the vapor flows over, you see the waves a little bit. That's probably fine, but if you see like big slugs of liquid, we need to probably stop it. Okay. If you see mixed phase through the rotometer, okay, shut it off. I think I have enough in it. I'm gonna check it one more time before we start next week. The liquid level here should be above the outlet right here. Okay. So the high pressure receiver, this component, is basically just keeps those phases separate. So it's going to come in as it condenses in the condenser, and it should just draw straight liquid out of the bottom. If this is too low, once everything hits steady state, this is going to drop a little bit as the fluid runs through the system. But if it gets too low and it starts to pull a little bit of air, if the liquid level goes below this, you'll see a mixed phase in there. We don't want that. We'll have to stop it and pull some more into it. We have a method for that. You don't have to worry about that. But if you see it, let me know though. I'm going to try to make sure that doesn't happen. Other than that, not a whole lot to it. The refrigerant that we're using is 123. Not commonly used anymore, but it's from 2007, so they were using it at least at that time. Let's see. It's pretty much all the components. Questions? I guess we have to mention the colors. So if you just follow the piping real quick, if you start, I guess we'll start at the expansion. This is what we're going to be adjusting, right? So the yellow is between your expansion and your evaporator. Your green goes from your evaporator to the compressor. Red from the compressor all the way around to the condenser, and then orange from the condenser back to the expansion. Okay, so it's actually not that complicated. You can make those in the blocks, connect them, say what they are, add the little rotometer, right? And then put your pressure gauges and temperature wells. That's pretty much it. It's not, the sketch shouldn't be that complicated. It just looks busy. Okay.